Okay, Assalamu alaikum. So in this session we'll talk about slicing. We'll talk about the operator that is used for slicing operations in Octave. So before we get into slicing, let us again start with creating a matrix, and then we'll first learn how to access individual elements of that matrix. And after we do that, then we will learn about how to slice that matrix. So slicing means what it means, like slicing, जैसे कि इसका नाम है स्लाइस, का मतलब है किसी चीज़ का टुकड़ा. सो अगर हम किसी मैट्रिक्स या वेक्टर को स्लाइस करते हैं तो स्लाइसिंग का मतलब ये है कि हम उसका एक टुकड़ा जो है वो उठाते हैं और वो एक्सट्रैक्ट करते हैं. सो वो टुकड़ा हम एक्सट्रैक्ट कर सकते हैं फॉर रीडिंग और एक्सेसिंग और प्लॉटिंग और वटेवर, और उस टुकड़े को हम एक्सेस कर सकते हैं फॉर चेंजिंग एज वेल. यानी हम बजाय इसके कि पूरे मैट्रिक्स या वेक्टर को चेंज करें, हम उसके किसी पर्टिकुलर स्लाइस को चेंज कर सकते हैं. सो इस सेशन में हम इस बारे में सीखेंगे. तो पहले हम ये सीखते हैं कि किसी भी मैट्रिक्स या वेक्टर के इंडिविजुअल एलिमेंट को हम कैसे एक्सेस कर सकते हैं. सो उसको सीखने के लिए हम इस तरह करते हैं कि अगेन हम एक मैट्रिक्स क्रिएट करेंगे, फिर हम उसके इंडिविजुअल किसी एलिमेंट को एक्सेस करेंगे, और उसको एक्सेस करने के बाद फिर हम यूँ करेंगे कि हम स्लाइसिंग ऑपरेशंस को देखेंगे. ठीक है. सो इंडिविजुअल एलिमेंट्स को एक्सेस करने के लिए पहले हम मैट्रिक्स को क्रिएट करते हैं. ये ऑलरेडी वर्क स्पेस में कुछ वेरिएबल्स हैं, मैं उनको क्लियर कर देता हूँ. ठीक है. Then I'll create a new matrix. So say for example I want to create a new matrix. This would be a two-dimensional matrix, और मैं किसी built-in function को यूज़ करना चाहता हूँ. So let us create an identity matrix. ठीक है. And how do we create an identity matrix? So we use the I function. So identity matrix is denoted by the symbol I, that is the letter I, and here we have a MATLAB or Octave function EYEI to generate an identity matrix. तो आप identity matrix को जब generate करते हैं तो आप you write the name I and then you pass on arguments to this function. So I, ये जो I है, this is a built-in Octave या MATLAB function, और इसको हम कॉल करते हैं to create an identity matrix. और identity matrix किस ऑर्डर का हम क्रिएट करना चाहते हैं, सो यू कैन स्पेसिफाई द ऑर्डर. सो आइडेंटिटी मैट्रिक्स इज ऑलवेज अ स्क्वायर मैट्रिक्स, तो आप उसको यूं भी क्रिएट कर सकते हैं बाय स्पेसिफाइंग 3 by 3. यू कैन से A इज इक्वल टू I 3, 3, सो 3 by 3 ऑर्डर का आइडेंटिटी मैट्रिक्स क्रिएट हो जाएगा. और यू कैन से A इज इक्वल टू I and just 3. सो सिंस इट इज़ अ स्क्वायर मैट्रिक्स, तो ये अंडरस्टूड है कि उसमें नंबर ऑफ रोज और कॉलम्स जो हैं वो इक्वल होंगे. सो आइदर वे यू कैन क्रिएट एन आइडेंटिटी मैट्रिक्स. अच्छा, अब हम इसको थोड़ा सा और मॉडिफाई कर लेते हैं, यानी इस आइडेंटिटी मैट्रिक्स को हम थोड़ा सा चेंज कर देते हैं. से इसको हम मल्टीप्लाई, चेंज करना ज़रूरी नहीं है, बट सिर्फ उसको ताकि वो वैल्यूज़ ज़रा डिफरेंट सी हों 1 0 से, इसलिए मैं चेंज कर रहा हूँ. सो से हम इसको मल्टीप्लाई कर देते हैं विद 2, और फिर हर एलिमेंट के साथ हम 3 ऐड कर देते हैं. से फॉर एग्जांपल दिस इज़ व्हाट वी डू. तो क्या होगा इस स्टेप में, हम क्या कर रहे हैं, हम मैट्रिक्स ए के हर एलिमेंट को मल्टीप्लाई कर रहे हैं विद 2. ठीक है. तो ये डायगोनल पे आपके पास 2 2 2 हो जाएगा, और ये 0 हैं तो ये 2 से मल्टीप्लाई होने के बाद भी 0 रहेंगे. और इसके अलावा हम हर एलिमेंट के साथ 3 को ऐड कर रहे हैं. सो डायगोनल वाले तमाम एलिमेंट्स 5 5 5 हो जाएंगे, और इर्द गिर्द के तमाम एलिमेंट्स जो हैं वो हमारे पास हो जाएंगे 2. ठीक है. तो 5 2 2 5 2 सॉरी 2 5 2 2 2 5. तो ये हमारे पास 3, हाँ 2 से मल्टीप्लाई कर रहे हैं और 3 ऐड कर रहे हैं. ठीक है. सो हमारे पास यहाँ पे 5 3 3, सिमिलरली 3 5 3 3 3 5, ये सूरत हाल हो जाएगी. सो दिस इज़ व्हाट ए इज़. ठीक है. अच्छा, अब अगर फर्ज कि हम चाहते हैं कि हम इस मैट्रिक्स ए के इंडिविजुअल एलिमेंट्स को एक्सेस करें, तो वो हम कैसे करेंगे. तो वो हम यूँ कर सकते हैं कि अगर हम ए के किसी इंडिविजुअल एलिमेंट को एक्सेस करना चाहते हैं, सो फर्स्ट ऑफ ऑल वी नीड टू स्पेसिफाई कि वी नीड टू स्पेसिफाई और राइट ए, और उसके बाद विद इन दीज पैरेंथेसिस वी नीड टू स्पेसिफाई द इंडेक्स of the element in A. अब since ये एक 2 डायमेंशनल मैट्रिक्स है, ठीक है, इसमें रोज हैं और कॉलम्स हैं, तो हर एक इंडिविजुअल एलिमेंट का के 2 इंडेक्सेस हैं, एक उसका रो इंडेक्स है, एक उसका कॉलम इंडेक्स है. फॉर एग्जांपल दिस इज़ द फर्स्ट रो. सो इसमें ये जो एलिमेंट है 5, ये रो नंबर 1 में है और कॉलम नंबर 1 में भी है, तो इसका रो इंडेक्स भी 1 है, कॉलम इंडेक्स भी 1 है. सो इफ़ आई से A11, ठीक है, तो यानी विद इन पेरेंथेसिस इफ आई स्पेसिफाई 1, 1 एज द इंडेक्सेस, तो क्या होगा, मेरे पास आउटपुट में 5 प्रिंट हो जाएगा. ठीक है. अच्छा, अगर मैं इस एलिमेंट को एक्सेस करना चाहता हूँ, ये वाला जो 3 है, तो ये इट एग्जिस्ट्स इन द थर्ड रो सेकंड कॉलम. ठीक है, तो इसका जो इंडेक्स है वो है 3, 2. तो इफ़ आई स्पेसिफाई दिस इंडेक्स, तो मेरे पास ये जो एलिमेंट है वो एक्सेस हो जाएगा. अच्छा, सिमिलरली आप यानी इस तरह से हम इन एलिमेंट्स को एक्सेस भी कर सकते हैं. एक्सेस का मतलब रीड कर सकते हैं, इनको हम चेंज भी कर सकते हैं. मतलब अगर मैं यूँ कहूँ A,1,1 इज इक्वल टू से -6, ठीक है, तो ये जो एलिमेंट है पहली रो और पहले कॉलम में, ये जो एलिमेंट है जो कि अभी 5 है, दिस वुड बी रिप्लेस्ड बाय -6. ठीक है. सो जब ये रिप्लेस हो जाएगा तो पूरा मैट्रिक्स A आपके पास प्रिंट हो जाएगा. Similarly, we accessed this element A32. तो अगर फर्ज किया हम उसको चेंज करना चाहें, so we can change that element as well. तो उसको से हम सेट कर देते हैं to 7. ठीक है. So A32, the element in third row and second column, उसको हमने चेंज कर दिया. ठीक है. अच्छा, so this was about accessing individual elements. Accessing individual elements in a matrix, and similarly the same applies to a row. For example, हम एक row vector create कर लेते हैं. So we can create a row vector like this. Say let us create some random row vector. ठीक है. So हमारे पास B is a row vector, and let us initialize B with random values. और उसकी जो dimensions हैं वो हम यूँ समझ रख सकते हैं कि this would be a row vector with, so 1 is the number of rows that we want to have, and say 4 is the number of columns that we want to have. So we are creating a random vector, a vector of random values, in this case 4 random values. ठीक है. अब इसमें अगर आप किसी इंडिविजुअल एलिमेंट को एक्सेस करना चाहें, say we want to access this element, ठीक है, so this element can be accessed, since this is a vector, ठीक है, so I can specify, ठीक है, just the row index. ठीक है, there is just 1 dimension. So if I specify B3, I should be able to access this element. ठीक है. If I specify it like this, first row, third column, ठीक है, so it should also result in the same thing. ठीक है. So you can do it either way. So MATLAB understands, or Octave understands, that this is just a row vector. It has only 1 row. If it were a column vector, you could do the same thing. So say for example I change it into a column vector. How can I change it? I can say B is equal to B transpose. So now it is a column vector. So if I want to access the same element, say I want to access this element, so I can say B3, ठीक है, so I will get the third element. So this is a column vector. It has just 1 column, multiple rows but just 1 column, so I can access it like this, or I can access it this way. So this is the third row and first column. ठीक है. So either way I can access this element, and like it would be fine. So if you access a vector as a 1-dimensional array, this is fine. In a 1-dimensional array, you only need to specify just the index along that 1 dimension. If however you want to access or treat this column vector or this row vector as a 2-dimensional array, so you can do that as well. So you can specify for any element, you can specify the values or indexes for both dimensions, and you would still be able to access the element correctly. Okay. So internally, like MATLAB, it stores or treats everything that you basically create as a multi-dimensional array. So that is like always the context in which this data is stored or operated. So you can access it either way. Okay. So this was about accessing individual elements in a vector or a matrix, and we did it for both the cases. Now let us clear this display so that we can get rid of some of the clutter, and now let us get back to slicing, the main topic for this session. So this is A. Now what we want to do is we want to access different slices of A. A is a two-dimensional matrix and we want to access different slices of A. ठीक है, हम इसके मुख्तलिफ टुकड़े access करना चाहते हैं या टुकड़े करना चाहते हैं, जैसे भी आप उसको समझें. So if you were to access a particular row, ठीक है, say you want to access just the second row. So we want to access just this row, ठीक है. So how can you access the second row? So all you need to do is you need to specify, actually you want to access a row of A. So first you need to write A, then these parentheses. Within these parentheses you need to specify, okay, I want to access the second row and I want to access all elements of that second row. So in order to specify all elements we use this symbol colon. Okay? So this basically, now we are doing a slicing operation. We are accessing this slice. Okay? So we are taking out this slice. Achha. One point I didn't mention, I mentioned in class, but in this particular session I didn't mention. Indexes, row indexes and column indexes in Octave and MATLAB, they always start from 1. Okay, so this element is at row, is in the first row and first column. Why do we need to clarify it? Since you guys, like, you come from your matriculation and FSC background, and in there, like, you have used matrices, and there also the indexes start from 1 1. But those who like use C++ or C or Java or any other programming language, mostly there the indexes for arrays, they always start from 0. Okay, so there the index always starts from 0 and it goes up until the length of the array minus 1 if it's a one-dimensional array. If it is a two-dimensional array, then along each dimension you have to calculate, the index goes up until length along that dimension minus 1. Okay, so in Octave and MATLAB, the row and column indexes, they always start from 1. Okay, so this is consistent with what we normally do in mathematics, although it doesn't make a lot of difference, but some people, if they are used to doing, if they are used to accessing individual elements of matrices with indexes starting from 1, so when they move into C++, they usually have some trouble adjusting to that, where C++ basically does thing with a 0 index, 0 as the starting index. Anyway, it's not that big a deal. Okay, so if you want to access the second row, this is how we can access the second row. So we want to access the second row of A, so you need to specify A, the second row. So first you specify the row index, then the column index. We are not specifying any entry in a specific column. We want to access all the columns basically. So second row and all the columns. So that is the second row, the entire second row. Okay? So when you press enter, so you will get the second row. Okay? If we want to access the third column, say if I want to access this third column, so how can I do that? So if you want to access third column of A, so this is what you need to do. You need to specify I want to access some element or some row or some column of A. This is how you specify. You write A and then you provide these parentheses. Within these parentheses, then you specify which slice of A do you want to access. This time we want to access the third column. Okay, so it is the third column and all rows in that column. So we are going to access the entire third column. Okay, we are going to access the entire third column. Okay, so if you press enter, so you will get the third column. The third column is 335. Not only can you do this for reading, like here we accessed it, so we read it and we got the row entries printed on the command window. Okay, or the column entry is printed on the command window. Not only can you do that, like you can not only can you read it, but you can also modify it. Once you have access to a particular row or column, you can always modify it. So if we want to modify, say, the second row, so this is how we can modify the second row. So here you can specify new values, entirely new values for the second row. So how can we specify those values? Like say, you just specify this is a row vector with 3 elements. So all you need to specify is a row vector with 3 elements. And that will replace this row vector. So we replaced this row vector in A. Okay, so this was A, and this is how we replaced it with a new row vector 789. Similarly, we can replace this column vector. Now this is A. So if we want to replace the third column, so this is how we can replace the third column. First, access the third column. So all rows in third column. So when we write that, we get access to the third column. And now we want to replace this third column. So how can we do that? So you can do it like this. Like you can say for example, I want to replace it with 3, 2, 1. So now this is a row vector. This is a row vector, and this is a column vector that I'm trying to replace. So one thing that you can do is you can make it a column vector by putting semicolons between each of these elements. Okay, so this is now a column vector. So you can use this column vector on the right, this column vector on the right, to replace this column vector on the left, which happens to be the third column in matrix A. So you can do that. Okay, and it has been replaced. Or you can do something like that. For example, say we want to replace the second column. Okay, we want to replace the second column. So first access the second column of A, and now we want to replace it with something. So what do we want to replace it with? Say for example, we have this row vector 879. So we want to replace this column vector with this row vector. This cannot be done. So what we can do is, like, if you find it difficult to type these semicolons and typing in space characters is easy for you, so you can take the transpose of this row vector and convert it into a column vector. So now this whole thing is a column vector, and you can use this column vector to replace this column vector. Okay, so if you do that, so you replace the second column with this column vector. Okay, so this is basically how slicing works. This was simple. Okay, this was simple. Say we can do much more complicated slicing than that. Much more complicated. Say for example, let us try another slicing operation. Say for example, this is A, and say for example we want to access this. We do not just want to access a row vector or a column vector as a slice, but we want to access a matrix as a slice. Okay? Say for example, I want to access this slice, this 2 by 2 sub matrix. Okay, 7291. Say if I want to access this one, how can I access this one? So this is a slice of A, and this slice basically it goes from, so like here I need to specify, like, look at this thing. So first I need to specify row or rows, and then I need to specify column or columns. Okay, so this is how I access either an individual element of A, or a row vector of A, or a column vector of A, or I can extract a sub matrix of A. This is how we do it. So right now we are not interested in accessing a row vector or a column vector. We are interested in accessing a sub matrix. Okay, so a sub matrix. So say for example we want to access 7291. So this sub matrix, like, it spans the rows 2 and 3. So it is present in the rows 2 and 3. So we need to specify that we need to access rows 2 and 3. How can we specify that? So we need to specify that as a list. So 2 and 3. So this is how you specify a list in Octave. So within these square brackets, we have specified the indexes of rows that we want to extract. And here we can specify the indexes of columns that we want to access. So 7, 2, 9, 1, these are from rows 2, 3 and columns 2 and 3. Okay. So if I specify 2, 3, I want to access the submatrix that is spread over the second and third rows and the second and third column. So this is that submatrix. Okay, 7, 2, 9, 1. It is spread over these two rows, 2, 3, and these two columns, second and third, 2, 3. If I do that, so I'll get this submatrix. Okay. So this is how you can extract not just an individual row vector or column vector, but a submatrix, any submatrix. Okay. So you can try like different, but by any I mean like it should be rectangular. The matrix should be rectangular. So it should be a matrix by definition. Then you can access it. Let us try a much more difficult one. Say for example we want to access this one, -6, 3, 3, 1. So we want to extract this submatrix. So the submatrix that we want to extract should have these elements, -6, 3, 3, 1. So how can we access that? Again, go through this process. So we want to access some slice of A. So this is how you specify if we want to access some slice of A and then these parentheses. And A is a two-dimensional matrix, so we need to specify values for both the dimension, the row dimension and the column dimension. Okay, so we need to have this comma in between. Now the slice that we want to access is this slice, -6, 3, 3, 1. Okay, so this slice, like the rows that we need to access for accessing this slice, those rows are the first row and the third row. -6, 3, they are in the first row, 3, 1, they are in the third row. So we need to specify this. Okay, we need to access the first row and the third row. These two rows we want to access. And similarly, the columns again are the first column and the third column. We need to access the first column and the third column. Okay, so these are the rows that we want to access. These are the columns that we want to access. So the intersection of these two rows and these two columns, they will basically generate the submatrix for this particular operation, and that submatrix would be -6, 3, 3, 1. So you can we can slice this matrix in very interesting ways. So this is this slice, -6, 3, 3, 1. Okay, I can access it, I can change it as well. So I can say this particular slice of matrix A is equal to something. Okay, what something? So let us say I want to zero all these elements. Okay, so I can say zeros, 2 by 2. So this is a 2 by 2 slice, and I want to initialize the slice with all zeros. So this is how the matrix A would look after we access the slice and initialize this with all zeros. So I hope this session would help you understand slicing. Slicing is very interesting, a very powerful operation. You can use the colon operator to do slicing. There is another use for the colon operator, like we use it to create vectors. Say for example, like you can say C is equal to 1 to 10. Okay, so it will create a vector C, and that vector will have these values. The initial value would be 1 and the final value would be 10, and by default each value would be separated from the next value by just 1. Okay, there. So the step size by default is 1. You can change the step size. You can say 1 to 10 and a step size of 3, say for example. Now we want the start value to be 1, the final value to be 10 or something less than 10. Okay? Because we have chosen an interesting step size. So the first value would be 1, the second would be 4, the third would be first would be 1, second would be 1 plus 3, 4, third would be 3 plus 4, 3 plus 3, sorry, 4 plus 3, 7, and the fourth would be 7 plus 3, 10, and that would be it. So this would be a rather shorter sequence. Okay, so it has just 4 entries. So the first entry is 1 and the final entry is 10, and the step size is 3. If you change the step size, 10 may not appear at all. Okay, so in this case you will not get 10. So the first entry would be 1, second 5, then 9. That would be it. Okay, so we cannot get 10 in this particular case. Why? Because this is the step size that we chose, so it cannot deliver us 10. So after this the value becomes greater than 10, that is 13. So 13 cannot be a part of this sequence. So when you use this operator for creating a vector, so you should be aware of the intricacies of generating it. Although it's not that complicated, it is simple. Okay, that's it for this session. Assalamu alaikum.